But yeah, welcome to our training today. My name is Itzel Torres with 3C Run. I've started recording the scores, which will be posted on our 3C Run on demand page, and we'll send it to you all after this training. We have Judy Rachel with us today that will walk us through elements of the whole house assessment, the home energy audit, explain. So a lot coming, but before we get started, I just have some housekeeping slides and a little bit about 3C Run. So as you are all probably really accustomed to Zoom now, we just ask that everybody make sure they are on mute throughout the duration of the course. And if you would like to verbally participate, please raise your hand in the participant section and we will call on you to unmute yourself, and we encourage you to participate and ask questions in the chat box as well. Next slide, please. A few words of who we are. We are the Tri-County Regional Energy Network. We are a collaborative partnership between San Luis Obispo, Santa Barbara, and Ventura counties, working to improve energy efficiency in our region by offering free programs and services for building professionals and households. 3C Run is funded by ratepayer dollars, which are collected through the Public Goods Charge Fund and our utility bills. 3C Run currently offers 3 programs. Next slide, please. The first one being our Energy Code Connect program, which serves building professionals by offering Title 24 support. Within the Energy Code Connect program, we offer our Energy Code Coach service, which is an over-the-phone, online, and in-the-field support for Title 24 related questions, both for residential and non-residential projects, and trainings as well. Next slide, please. Another program we have is our building performance training program, which serves building professionals by offering technical and soft skill trainings related to building science principles, high performance buildings, marketing, and communication techniques. Next slide, please. And we have our home energy savings program, which incentivizes contractors and helps residents save money and make their homes healthier with energy efficient upgrades through incentives and rebates. And with that, I'll hand it over to Judy to get us started for the day. Thank you so much.
All right, thank you. So hi, everyone. Today's 2-hour webinar is going to be rather a high-level outline of how to perform a home energy audit. And home energy audits are based in building science, and they implement the whole system approach to a home's performance. I have found that the word energy in home energy audit is pretty much always misunderstood. People take it to simply mean the dollar amount of their electric and gas usage. But the reality of an energy audit is much more far-reaching than gas and electrical use. It is actually how energy in a broader sense moves through the house, how heat, air, and moisture flow, and how those flows are impeded. So houses are really complex systems, and they're made up of various components. The enclosure and the mechanical systems interact with each other. The whole house as a system can impede the flow of energy, it can increase the flow of energy, it can restrict the flow of energy. So depending upon how all of that is working, the home can be supportive of occupant health or, unfortunately, negatively impact occupant health. The flow of energy can have a negative or a positive impact upon the durability of the structure. It can be conducive to thermal comfort or make it basically impossible for there to be thermal comfort. The energy flow impacts indoor air quality and also the safety of the occupant within the home. In order to have a durable, healthy, safe, comfortable, and low fuel energy usage homes, we need to make the system work correctly and effectively. And we do this by understanding the science behind how energy flows. The natural forces of the world really are pushing towards equilibrium. And therefore, energy naturally flows from areas of high concentrations to areas of low concentration. There's more energy where pressure is high. So energy moves from a high pressure area to a lower pressure area. There is higher energy when something is hotter than when something is not as hot, be it air or be it a physical object. So hot moves to less hot, and the same with moisture. Where there is moisture, the flow is towards where there is less moisture. Another piece of nature's drive towards equilibrium causes any energy that is lost from our houses to be made up by energy entering the home. And so we're typically concerned about heat or moisture, both of which move in air. And we measure that in CFM, or cubic feet per minute. So for every cubic foot of air that leaves our buildings, there will be another cubic foot of air that enters the building. And their energy states will probably be different because the interior of our buildings are typically hotter or colder than outside and often have different moisture levels as well. Another interesting factoid about energy is that no energy is lost in this process of this movement or flow. The energy may change form from, say, liquid to vapor, but no energy is actually lost. There are a number of things that we already know about homes. We know that no matter what type of conditioning system is being used in the home, a tighter home will be easier to condition than a leaky home and at a lower cost. We know that bulk moisture, water, can have devastating effects on the durability of the house and the health of the occupants. We know that we want the enclosure to have the ability to dry should it get wet. We know that relative humidity levels, which is the amount of water vapor in the air, needs to be maintained within the range of 30 to 60% for both durability of the building and occupant health. We know that homes, we can be the masters of the indoor air quality through filtration and ventilation when we have a well-sealed home. So the home energy audit is allowing us to do a thorough investigation of the house to determine how close or far away this home is from our ability to control the energy flows impacting it, which in turn allows us to provide a comprehensive work scope that will provide substantive solutions for the home. This is a high-level list of what an individual would be doing during the home energy site visit. The first three are pretty much done in order as listed. And after that, there's a lot of overlap. So the inspection becomes much less linear. And the auditor needs to find their own flow through the house, and they're going to end up kind of, coming and going inside, outside. Hopefully they won't have to re-enter the attic or crawl space more than once, but it can happen. Something that is noted, in one part of the house may need to be inspected further on the opposite side of the assembly. So, something you see in the interior, you may want to look on the exterior, or if you see something inside the house that is adjacent to that is in the ceiling plane, then you may want to look in the attic to see what you can find about why you're seeing that effect in the house, and the same thing with the crawl space. The auditor or the inspector needs to learn a number of tests and then make on-the-spot decisions as to what tests fit the various situations within the house. And you do the tests that will provide you with the information you need and that are possible in that house. And you don't do the tests that are not going to enlighten you in this house or potentially can't be done in this particular house. And often that is for safety reasons or accessibility reasons. So even though there are all these tests that we can do, we don't absolutely do them all in every house. And we need to make those decisions as to what is going to give us the best information and what we can do. Here's a flow chart of the big picture of the home performance process itself. And in this webinar, we'll be looking at the test-in and the report building. A third-party individual who performs the home energy audits, that's great to have somebody who's third-party. But audits really help the home performance contractor. So doing an audit as part of your business model as a contractor is tremendously helpful for you. As a home performance contractor, the energy audit gets your eyes on the house. You've performed the diagnostic testing. You personally have gotten to know the house and the client. You know what you can do and would like to do to make the house perform better. You're not playing catch up by reading somebody else's report and trying to figure out, what they saw and what they're saying. You're not trying to, you're not kind of moving in on somebody else's rapport with the client. So testing is one of the ways that distinguishes the home energy audit from a contractor just going out to a home and meeting the homeowners and taking a quick look and giving their opinion. Testing provides quantifiable, accurate information as to how various components of the house are functioning, which then informs us as to how the house as a system is dysfunctional. There is information and tasks that are to your advantage to complete before you ever arrive at the house to perform the audit. And these tasks prepare both you and the client for your visit. They qualify the client, you begin gathering the information about the house and the client's wants, and you kind of find out, what exactly you're going to be walking into. Utility bills are incredibly useful for the information that they can supply us. Pre-retrofit, they provide an idea of the home's baseload energy usage versus the home's heating and cooling energy usage. And then post-retrofit, they can provide basically a scorecard of how successful your work has been. The utility bill disaggregation will provide you with the main target for your proposed improvements. If the seasonal heating and cooling loads are high, then there are probably issues with the building enclosure, the insulation, and the HVAC system. And if the main energy hog is base load, then you'll want to focus more on appliances, lighting, and possibly water heating and plumbing. We're going to walk through a utility bill disaggregation right now. So this is something that you can walk away with and learn to do for your home and for your clients. The utility bill disaggregation, it pulls apart the energy consumption data and it separates it into basically 4 major energy use categories in your home: heating, hot water usage, air conditioning, and other electrical loads. Ideally, we want to do this utility bill disaggregation before the on-site inspection because it tells us a great deal about which energy saving opportunities are the most promising and therefore what systems are best to focus on during your site visit. The heating and cooling energy savings or the baseload energy savings. It's not a big deal if we don't manage to do it pre-visit, but it is helpful if we can get the information and get it done before you head out to the site. Yes, you will get the slides after the presentation, Joseph. So, although the utility bill disaggregation allows us to make a good estimate of how a house is using energy, I want to stress that it's not an exact science by any means. And as such, there's really no perfect way to pull the bills apart. So I'm going to explain how it was done on this slide. And you might hear about or learn slightly different approaches. Another approach is in a book called Measured Home Performance. That's by Rick Chitwood and Lou Harriman. An excellent book, and it has a slightly different method. And then also Residential Energy by John Krieger is another really good book about energy usage in our homes and the energy audit and the building science. And he has another method in his book as well. So they're all good approaches and they'll all get you thinking about, what you should be considering when choosing the approach that works best for you. This example is an all-electric house. So the previous slide, that graphic was for a home that has both electric and utility bills. So when we've got a house that has electric and gas, electric and gas bills, you're going to end up basically doing the disaggregation for the two different fuel sources. And then in an all electric house, you do it for just the one source. So this this example is also graphing the dollars spent each month. Now, personally, I like to look at the dollars spent, but I graph and do my calculations on the actual energy usage. So, either therms if it's gas or in kilowatts for electric. But in this example, the month with the lowest dollar amount was chosen as the base load dollar amount. So that's why that's in green. It's showing you that was the month that at least had the lowest dollar amount. So the assumption is also that it had the least energy amount used. And so that's what we're choosing as our base load per month. And so base load is things like the refrigerator, the lighting, TVs, computers, those kind of loads in the house. And then what we do is we multiply that number by 12 months. And that gives us a good estimate of the annual cost of the home's base load energy use. So in this example, these occupants over a 1-year period spent $4,850 on water heating and other base electrical loads. And then next, we look at everything above the base load. So in the summer months, everything above the base load is considered to be air conditioning. And then in the winter months, everything above base load is considered to be heating. And base load can definitely be a huge area for improvement in energy efficiency. So don't neglect the impact of working on base load issues and what that can deliver for your clients. So let's take a look at the results of our analysis. So we found out that this house is 6,000 square feet, nice size house. Adding up the excess usage in the summer and winter, we came up with $586 for cooling and $1,941 for heating, for a total for heating and cooling of $2,527 spent for the year on space conditioning this house. Now, by dividing the annual space conditioning dollar amount by the house's square footage, we find that the space conditioning cost per square foot is 42 cents per square foot. So this is where doing many utility bill disaggregations comes in handy. You'll begin to get a sense of well-performing homes, which are typically those that you get to retrofit, and poorly performing homes, which are typically the ones that you're going out and doing your home energy audit on. So in your area, you start getting that sense along with a knowledge of the prevailing utility rates by seeing all these bills. And so with this information, you should form a metric for what a well-performing home should cost to space condition. And if you were to figure that out post retrofit, that you were getting homes down to, say 20 cents per square foot, now you have a target that you're confident in meeting at current utility rates and something concrete to tell a client to expect as dollar savings. Now, we can also see that these occupants spend more of their energy dollars on baseload items than they do for space conditioning. And this gives us the clue that we should do a thorough examination of their appliances, their entertainment equipment, lighting, computers, office equipment, just all the kind of things that they use and have plugged in their home all the time, to help them figure out ways to reduce their baseload energy usage. But just because their baseload usage is greater than their heating and cooling, their space conditioning usage, that doesn't mean that there still isn't ample saving opportunities in the area of space conditioning, but we really need to look at both in this house. So this is a comparison of two houses with 1 year of utility usage. These two homes were built at the same time as part of a development, and they're next door to each other. The home with the conventional forced air heating and cooling system used a home performance contractor for all of the home's energy features. So meaning that contractor did the air sealing, the insulation, the HVAC design, and installation. And having control of those pieces during construction, the home performance contractor was able to create a home that cost only 9 cents per square foot to heat and cool, compared to 42 cents per square foot at that house next door, based on the energy costs at the time of this comparison. That geothermal house did not have the expertise of a home performance contractor. And it's this house's utility bills that we were just looking at the disaggregation of. So even though their baseload usage was high, there's actually quite a bit of savings they could receive from a space conditioning retrofit to get their home from this 42 cents down to something like 9 cents per square foot. And one last point is that the home performance contractor did not go to some kind of extreme measures for his results. Basically, he made sure that all fire blocking was in place for his air sealing. His crew is just proficient at actually installing insulation correctly. And he did the load calculation to properly size the heating and cooling system, and then he installed the system well. I'm just going to take a quick look at some of the questions or comments that came through. I'm not going to talk at all about any kind of rebate programs. This webinar is purely about the home energy audit process. And then another question is how to evaluate household that has EV that changes or in baseline. You have to figure out, where, it's EV is probably going to end up being is baseline. You can potentially get a sense of when they tend to plug their car in, but it's going to end up in the baseline. So the auditor really needs to be an expert in the region that they work in and in building science. And they need to know what's going on in the environment they work in. Is there anything particular about the region that will need to be factored into their evaluation of a home site? Is the soil sandy? Is it wet? Is it expansive clay that moves foundations? It turns out that we all actually need to be concerned about radon. Are there any other soil gases in the region of concern? Are there any Superfund sites in the area? If there are unhealthy levels of pollutants in the air, the recommendations for filtration and ventilation systems may change. If there are soil gases or pesticides, they will want to develop a strategy for keeping those out of the home. And they need to become proficient in protecting homes from wildfires. Prevailing winds are another important consideration that affect our buildings and their energy performance. So those are all things that we need to be figuring out about the home, its site, and what's going on in the region that we're working. We should be getting clues about the neighborhood, the house, and its condition as we drive up to it. The auditor needs to understand the occupants, their values, and their habits. Is the house being maintained or does it need maintenance? Have there been upgrades in addition to the original structure? Their car can possibly tell you how interested they are in energy efficiency. Do they have a hybrid or an electric car, or they have gas guzzlers. A quick impression of the exterior of the house, noting anything that should be explored further during your full investigation and inspection. The first thing that the auditor will do after introductions is perform the occupant interview. And the point of the interview is to determine, what the occupant wants for their home. They'll probably not be aware of everything that you can provide them with, nor how truly extensive the inspection is. They'll learn that in time, but first you need to learn what they know, what they don't know, what they think they want out of your inspection, what their goals are for their home, and as much information about the house and how they operate it as you can get from the individuals who actually live there. You get only one day in the house, and typically they will have years of experience in the house. So you can glean a lot of information about the other seasons, when you're not there, and just more information about the house than what you can ever gather in a day. You need to find out the number of full-time occupants. Is the home occupied for parts of the day, or is someone home all the time? Do people work out of the home? We're looking for use patterns. When a home is occupied, it should use less. When a home is unoccupied, it should use less energy than a home that people are in all day long. Do they open windows to help cool or air out the house? Do they use the bathroom or kitchen exhaust fans? We want to find out about their energy saving strategies and any equipment. Later, the auditor should reinforce correct understandings, yet tactfully correct any misunderstandings about what saves energy in a home and what doesn't. IAQ stands for indoor air quality. We want to know if any member of the family has any breathing difficulties, running noses, asthma, allergies, gets colds often. Do any symptoms get worse when they're inside the house? Are there chemical or musty odors or indoor condensation, like on windows? We need to know about comfort in specific rooms. Asking the occupants to think about the hottest summer day and the coldest winter day, and where in the home is comfortable or uncomfortable. Who is comfortable and who isn't? Does one occupant disagree about the thermostat setting? And when during the year does this happen? And for how much of the year does this happen? We need to determine if the entire conditioned area is being utilized by the occupants. Sometimes an elderly couple may no longer use, say, the second floor living space, or rooms that have been too difficult to condition have been vacated and the supply vents have been closed off in some way. Ask about the length of time that an occupant has lived at the current address, how long they plan to stay. This will help you identify an occupant's familiarity with long-term issues such as flooding or water intrusions during different seasons, how much benefit they'll gain from the work you'll propose to do to their home. If they're not planning on staying in the home for very long, that is probably going to change the work scope that you potentially want to offer, and definitely the work scope that they will want to enact on their home versus somebody who this is their forever home. So the more information you gather, the better, and the more relevant a proposal you're going to be able to provide them. We really need to explain the investigation process. It's quite intensive. You'll be examining both the interior and the exterior of the house. You'll be exploring the attic and the crawl space in homes with raised foundations. We need to alert the occupant to the potential for noise. The blower door and duct blaster are a little noisy, depending upon the fan speed. And then during worst case depressurization testing, you'll be turning all the fans on in the house and the dryer. So that's typically the noisiest part of your testing, and those fans stay on for a bit of time when you're doing the combustion safety testing. You'll need to configure doors and windows for some of your testing, and the occupants need to be made aware that there are times when you need to take control of the house, and that they will end up compromising your test results should they change the configuration of those doors and windows during your test. And always tell them the amount of time required for the test in, which is another thing that we call the home energy audit, is the test in. So typically inspections will take 6 to 8 hours, particularly if it's just one auditor out there doing the test. Place your customers at ease by explaining the tests and how they'll be conducted. Trust is an important factor in the process, and encourage customer participation in your testing. Firsthand experience builds buy-in. Many customers want to participate in the search for things like the air leakage sites, or at least be shown what the blower door discovers. Often they'll want to take a picture of the blower door setup in their home. An educated customer will know enough to let you do what you need to do to get your testing done. So first, there will be basically your visual inspections. And so I typically start with an exterior inspection. I'll get a quick walkthrough of the house with the homeowner or occupant, and then I'll head out and start my exterior inspection. So some of the main things being looked for are how is moisture being managed, and particularly bulk moisture, water in its liquid state, and how is the sun beating down on the walls and the roof and the windows. And we're looking for anything and everything to determine the strengths and weaknesses of the home's exterior, as well as clues to anything that may be happening inside the home. Take lots of pictures. Pictures will help ensure you remember the details of what you've discovered about the house. They're great for including in your report. Homeowners are not typically going to follow you up into the attic or crawl space, although I've had a few that have done that. If you have someone else writing the report, pictures allow them to check details without having to go out to the house themselves. These two pictures provide a ton of information. The picture on the left is of a sealed combustion furnace. The vent for the combustion gases, hopefully you can see my pointer, I'm circling this area here, where the vent for the combustion gases is supposed to be actually connected to the venting of those combustion gases. It's actually not connected inside the air handler cabinet. So the combustion gases are never actually making it to the vent. They're just spilling into the air handler cabinet. This air handler was actually in an attic above the hall of the second floor. So all those combustion gases, carbon monoxide, and all the other combustion gases are just spilling out into the attic and therefore making their way into the house. The picture on the right is an atmospherically vented water heater, and it doesn't have a draft diverter. Somebody just went and placed the vent directly over the heat exchanger and where the combustion gases come up out of the water heater. So this is incredibly unsafe. A downdraft through the vent pipe can extinguish the pilot light if it's still a gas water heater that has a pilot light, or if the burner has been lit, a draft can blow out the burner flame. And now we've got just gas leaking into the space around that water heater. And this can lead to an explosion. It can lead to a lack of oxygen within the space where the water heater is located. That's just not the way atmospheric water heaters are supposed to be vented, and it's unsafe. Trees and plants. So we're also looking at the landscaping around the house. Foliage in general, it needs to be carefully considered. It can provide shade and certainly aesthetics, but we need to consider the negative effects as well, such as how the roots will affect the foundation, or if the vegetation is too close to the building and therefore it's holding moisture up against the house walls and structure. Many sidings are what's called reservoir claddings, meaning that they absorb moisture. So it's important to have a capillary break between vegetation and the siding of our homes so that our homes are not continually being inundated with moisture. And then plants close to homes also invite insects, ants, and termites. And we need to provide some space between plants in the house to avoid negative impacts while allowing the clients to still take advantage of the natural beauty, the shade, and any buffering abilities from the sun and wind. So moisture in and around homes is the leading cause of structural damage. And moisture enters our homes in a number of ways through cooking and bathing and watering plants. Then there's kind of the exterior ways that water can enter our homes. Ground and surface water are usually the greatest sources of moisture in our buildings. And that being said, drainage systems and grading design, exterior damp proofing, and surface water diversion should all be considered and included in the recommendations when moisture problems are discovered around the exterior of homes. From various studies that have been done, we know about how much moisture gets into our homes from various sources. And so something like a 5-minute shower releases about 1/2 a pint of moisture into our homes. Whereas ground moisture, although highly variable, it can be as much as 105 pints in a day. And I'm not talking about like a rainy day. That is just literally the amount of moisture that can come up just through the earth and then end up into our homes in homes with raised foundations. So if we find moist soil in the crawl space, then we absolutely know that that crawl space is a significant source of household moisture. But even soil that appears dry can be contributing to moisture in our homes. And so far you can see where a lot of homeowners are a little bit surprised and potentially taken aback by the fact that you're looking at their landscaping, their vegetation, being so concerned about, moisture around their homes, and what does that have to do with energy? And so that's where that energy is really about energy in the broader sense and the flow of energy rather than energy in that dollar sense of just how many gas and therms we use and kilowatts of electricity. So the auditor needs to be looking for clues as to whether there are any water management problems on the exterior of the house. Water management problems often need to be solved before other measures can be performed. We don't want to seal an assembly that's getting wet. We don't want to trap any moisture in that assembly, and because that's just a recipe for disaster. So often during the audit itself, we're not able to determine all three of these mechanisms, identifying the source, determining the pathway, or how exactly that water is being transported. But it's something that if we notice what's going on and we can't necessarily identify all three of our needs to figure out how to solve this problem, that's something that you would be putting, still drawing to the attention and putting in the work scope that further investigation needs to be done to solve this issue before proceeding with the other measures, such as insulating the exterior walls that we would want to do to help this home perform better and have lower energy usage. So the amount of runoff from our roofs during a rainfall is about 1,250 gallons for a 2,000 square foot surface area roof. And I think after our last rains, a lot of us can absolutely believe that that number is a fact. 1,250 gallons of water pouring off of the roofs during a rain. So that's a lot of water. And we don't want to be dumping that kind of water right next to our homes. So during your visual inspection, you might notice a groove in the soil underneath that roof line. And then you'll often see the backsplash line on the cladding. And with an infrared, you may actually be able to, well, you can, as long as we can get the temperature differences that we need, you'll be able to recognize that cladding may still be wet. And really, we want that cladding to be able to dry within like 48 hours, which is often not the case. And if it lasts longer than 48 hours, now we've got the potential for all kinds of biological growths and problems with the claddings and any wood or any other materials within that assembly. So at this house and in this situation, I was able to identify the source, being rain, the pathway, over the edge of this gutter system. So the gutter system obviously was not sloped properly and it was filled with debris. So I was able to determine the pathway. And then the transport, was gravity down the wall. And this is one of those clues that tells us that we really need to take a look on the opposite side of the assembly to see if what's happening on one side of the assembly is also affecting through the assembly and to the other side of the assembly. So the paint on the drywall on the interior of this house was actually bubbling. This could have happened either way, right? I could have been inside the house and seen the bubbling of the paint on the interior of the house and thought to myself, I should go check on the outside, the opposite side of this assembly, and see what's going on. So you can get the clues, either way, and you need to remember and take note that you should be checking on the other side of the assembly. So eventually, we want to determine if this wall is able to dry quickly enough to not cause damage. And there's things that we need to include in the work scope to present to this client, because this is a serious problem. And it really needs to be corrected before adding any insulation to an uninsulated wall, which in my area, there are lots of older homes that have no insulation in the walls. And we can't just be randomly blowing in insulation, telling people that that's going to solve their problem, is just getting insulation in their walls, because those walls actually have better drying potential because they are empty than they will if we just go and blow insulation into them. So, some of the fixes are that, the rain gutter system is relatively easy and straightforward. The slope of the gutter needs to be corrected. The gutters need to be kept clean. So then that piece of the problem can be corrected. Unfortunately, damage has been done because of the amount of water. And so now there's more extensive work that needs to be done to fix to make sure that the interior of the wall doesn't have any kind of growth or wood that's been decaying, and the interior needs to be repainted, and that drywall needs to be replaced. So here's a couple of examples that clients typically don't realize that are kind of within the auditor's work scope again. But the picture on the left is showing, a downspout that is just depositing water directly to the stucco exterior of the wall. So, similar issue as in the last picture, just kind of different location of where the water is being dumped. And this time it's actually being dumped there. We're going to say intentionally, but incorrectly. We don't want the water running against and up to the walls of our homes. The picture on the right is an overhang that's not pitched correctly to drain water runoff to drain water runoff from the roof. So this is all part of what we need to be noticing as energy auditors. Stucco is hygroscopic. It means that it readily takes up and retains moisture. So these are things we need to know and understand about our cladding systems. And if the water is getting past the building paper, it's being absorbed by the concrete slab, then it may not be drying quickly enough to avoid structural damage. And so if the water is making its way into the wall system, the wood studs can wick the water upward through capillary action. The bottom of the studs may be in contact with a wet sill plate. And if that lasts for any length of time, it's going to cause durability issues. So we need to look for clues to any of these problems inside the house at these locations. And we need to check to see if the walls are insulated, that's one of the most difficult things to do, is to figure out often whether walls are insulated and where they're insulated and how well they're insulated. So we might need to do probing at switch plates to determine if there's insulation. Using an infrared camera can help us determine that. But uninsulated walls, as I said earlier, often have a much greater drying potential than insulated walls. And so That's why a lot of homes that have gotten insulation suddenly start showing problems when they never used to. It's because we've short-circuited that drying potential of those walls, and now there's the problems are showing up because those walls are not drying, and they were getting wet, and those moisture issues were not addressed before the insulation was put into those walls. And what about irrigation? I have found that in Southern California, at least, we get more water on our homes through our irrigation systems than we do from rainfall. And water from vegetation, including trees, moves by capillary action, and moisture near and in contact with our sidings or foundations are going to cause durability issues for the building. So we want our homeowners to water their landscaping, but not their homes. And it's our job to bring this to their attention. Having sprinklers up close to the home is not a good place for sprinklers. I recently had a client who changed their sprinklers out to a drip system, but the individuals that they hired to make that change still didn't understand that we don't want to be watering our homes. And so they had this drip irrigation system that was more than dripping, and they had it scheduled for something like 15 minutes a day, which even down where I am in Southern California, we do not need to water our landscaping for 15 minutes a day. And they ended up with all kinds of water problems through the foundation and underneath the crawl space. And just this picture is just showing the various growths and things that will happen on our walls when the moisture is up against our homes. So this is what we want in and around our homes. We want a drainage system around the perimeter of the home that carries the water away from the building to daylight. If the site doesn't allow for a drain to go to daylight, then special care should be taken to make sure that moisture stays away from the foundation. A gutter system for the roof, proper grading around the building, and a buried drywall possibly. And so, since we can't tell homeowners that they can't bathe or that they shouldn't have plants or pets or children, we need to offer them to control other sources, to control the sources of moisture in other ways and the other sources of moisture. So taking control of moisture as part of the energy efficiency upgrades is truly an essential first step towards a successful project. And in many instances, it's what I call a non-negotiable. It needs to be done before other measures can be done to the home. Water is that universal solvent. It corrodes metal, it dissolves glue, it warps wood, it weakens mortar. It decreases the effectiveness of insulation, and it provides habitat for biological organisms which threaten human respiratory health. So it's for these reasons that the home energy auditor really must fully examine the methods by which water enters homes and recommend steps to reduce and eliminate the pathways. Roof. We definitely need to take a look at the roof. We often need to crawl up on the roof and take a walk around. We need to examine flashing around chimneys, the just overall flashing of the roof, the vent caps, the chimney, the skylights, see if there's ventilation. We've got, a furnace vent here that's in total disrepair. At this house, I found that the power lines were disconnected from where they had been mounted on the roof. This is often the most thorough investigation that a homeowner is ever going to have of their home, and it's our responsibility to tell them what we find. And then during the inspection, you'll find a lot of issues that I broadly classify as deferred maintenance. And often these issues would end up getting covered up and potentially become inaccessible when our other recommendations for enclosure improvements are implemented. So when that's the case, those issues are non-negotiable. they need to be fixed before our other recommendations are implemented. And sometimes it's just good practice to let the homeowner know what you notice, since you may be the only person who's taken a good look at the house. And then if you're a contractor, if that's work that you can do, add it to your work scope. Then the homeowner can choose whether they want you to do that work as well or not. The picture on the left is actually outside. It's a little raised patio, and that is one of the columns that's holding up the patio roof. And you can see that it's just desiccated by termites. Water is the number one attraction of termites. And you can see that the post base down here, the metal post base, it's rusting. And we know that concrete is hygroscopic. It loves water and retains water and carries water. So but the big question is, where is the water coming from? Why is the concrete getting wet and not drying quickly enough that it's, resting this post base, and therefore kind of helping that colony of termites, be very happy with food and water. And then the picture on the right is I'm actually up on the roof. There's my little foot right there. Looking down, and I'm seeing that the rain gutter is filling up with leaves. And so this is a seasonal maintenance issue that's important to bring to homeowners' attention. They often, don't quite realize what's going on with their homes and some of these seasonal issues that they should put on their maintenance list or hire somebody to do these things for them. So, in a clogged gutter, can overflow, dump water at the base of the patio. If there's landscaping next to the patio or the patio is sloping towards the house, then the water is going to pool at the base of the patio or the house. So this potentially could be what's going on, is that water's overflowing. The sloping is towards the patio concrete becomes saturated. Those post beams are resting. Those post bases are resting. So you look around, try to figure out what's going on. And if you can't, then you may have to, put that in your work scope, that's something that needs to be explored further. And although this is time consuming, it's always a good idea to include measuring and sketching the house during the energy audit inspection. The sketch with accurate measurements and a volume calculation are necessary for your memory of the house's layout, for possible future load calculations, and for your bidding process. After that exterior inspection, we're going to move to the interior of the house. And during the interior inspection, we're looking for some of the same issues as outside, and some new things as well that are purely going to be inside: the supplies and the returns, ventilation, the baseload appliances. Can anybody type in for me what the issue is that I'm identifying in this picture that I took? Why did I didn't take this picture just to show everybody that cute horse? What exactly am I showing with this picture? So anybody want to type that in, what they see? Okay, so a lot of people are getting it. Yep, exactly. Exactly. For anybody who's looking at the chat. There is a supply that is being blocked. And that completely short circuits our heating and cooling systems. And with forced air heating and cooling systems, we cannot have blocked supplies or returns. That's going to compromise the performance of the system, the comfort of the occupants. So that we need to look for things like that. There is a kind of a three-part question in the chat. I will answer quickly. 2,000 square foot house built in 1970. How long does it take you to perform the energy audit? Depends on how complicated the house is. Like I said earlier, doing an energy audit is a 6 to 8 hour job. How long does it take you to write the report? It takes me hours and hours and hours to write reports. I do custom reports. I give a lot of information in my reports. It literally takes hours. I'm not able to charge enough for the amount of time that I put into writing reports. How much do you charge the customer for this service? Completely depends, and not something that I'm going to throw out any numbers during this webinar. Once again, we have moisture issues inside houses that we need to be looking at. The moisture issue may be obvious, but typically we only get clues that we need to follow up on. And sometimes that follow-up is actually asking the homeowner or occupant questions about what we're seeing. Water staining is really tough. It can be the remnant of an old issue that has been resolved. It could be a seasonal issue. It can be caused by high indoor humidity or a cold surface that drops below dew point, such as single pane windows. So sometimes moisture issues can be really difficult, but it doesn't mean that we shouldn't point them out and try to figure them out. Many indoor issues cause poor indoor air quality. So mold is obviously a moisture issue and a serious health concern. Air leakage paths can be bringing air into the house from the attic and the crawl space or the wall system. Leaky ducts are bringing in air from the space through which the ducts are run and distributing that dirty air throughout the house. If you see mold, and that's what we're seeing here, is mold. So now if you see mold, visually see mold, it needs to be remediated. It is mold. It needs to be remediated. Mold remediation expert, mold people are not allowed to say that. They have to, test a sample of it and send it to a lab. Lou Harriman is a moisture expert. He wrote the Measured Home Performance book that I mentioned earlier with Rick Chitwood. He said to me, Judy, if you see mold, it is mold. It needs to be remediated. So the source or the reason for the high moisture level, that really needs to be determined and taken care of. I'm not going to say there's no point in remediating it without figuring out why it's happening, but we really need both. We need it to be remediated, and we need it to not happen anymore. So we need to figure out why and fix that. And then this is the dirt streaks around supply vents is a sign of duct leakage. And I know that a lot of females in particular see this and try to clean it, but this dirt ends up getting impinged into the paint of the sheetrock, and they feel like they're bad housekeepers and there's something wrong with them. But this is impinged dirt from the duct leakage that is showing up. Other indoor air quality issues, unducted returns. In our older homes, I think it was our 2008 building code made unducted returns illegal, but I still see them all the time. In our older homes, I see them in newer homes that have had work done on them, even though contractors are supposed to, they're technically required by law to not leave an unducted return if they're working on the system, and yet they still do. This return on the left, this is actually a platform return in a garage. So the return itself is bringing air from the house. There's a grill over here in the wall that's bringing, return air from the house and going up into the air handler. But this platform return is in the garage where this homeowner parked. It was something like a 3 or 4 car garage. It was a big garage, and he loved his cars. So absolutely, the combustion from those cars being left running could get into this platform. It's completely unsealed and unducted and get distributed through the house. This is just another unducted return. This was it was a weird hallway return. And so somebody attempted to slap some mastic, but that's not ducting a return. Ducting a return is using either ductboard, sheet metal, or flex duct, and fully using those materials for the air pathway. Often I will remove supply grills to take a look for duct leakage, for indoor air quality, to see the size of the duct and possibly how well they're installed. And these pictures tell us all kinds of information. There's all kinds of duct leakage around this boot. This was in a bathroom, and we've got this incredibly small duct, and you can see the flex duct in both of these, and that it's not pulled tight. There isn't, there should have been a rigid elbow prior to this duct being connected to this boot. This being a fairly little bathroom, this supply grill is way too large to distribute the air and mix it properly. A 4-inch duct, might have been okay for this bathroom, but the grill itself is sized incorrectly and not installed well. And this is a living room supply. And there's no way that this little duct was big enough for the amount of air that actually was needed for this living room. The return grill itself might have been a decent size, but we need to look at the engineering data to see if that's truly the case. But anyway, these definitely are part of creating poor indoor air quality within this home. So have a couple questions. What about rooms that are not used and the homeowner has closed vents in rooms? And that's part of the education process when we're working with people. People completely short circuit the way that the heating and cooling system are supposed to be working when they close off any supply or block them or the returns. The whole entire system should have been designed and installed so that it is working as a system. And if we block part of that system off, we're creating all kinds of problems throughout the rest of the system. And the system should be air balanced. And so that each room needs a certain amount of conditioning. And so, what about rooms that are not used? Those vents still need to stay open, and the homeowner needs to be told that they will be completely short-circuiting the system if they close off a vent. We shouldn't be putting those registers at our grills so that homeowners don't have the opportunity to change our air balancing of the systems. And that's all things that need to be communicated to a homeowner. And often we have to negotiate when we're putting in supplies in particularly when we're putting low sidewall or floor supplies, that we need to negotiate space with our homeowners so that they know that they can't put furniture over that or something in front of that, and so if that's someplace where they really intend to put furniture, then we need to find another place to deliver our air from. What if the return you refer to is just a remnant of a shutdown gas forced air system? If it happens to be just a remnant, then you need to investigate whether it's an air leakage pathway into or out of the house. If it's not actually an air leakage pathway, then there is some interstitial space that is probably still open, and you need to decide whether that needs to be sealed or not to make the home just overall better off. And if it is actually a pathway that is truly an air leakage pathway, then it should be sealed in some way. And that just gets, once again, kind of negotiated with the homeowner, whether we just block that off and still leave the vent so that look is still there, or whether the vent's removed and the drywall is actually, fixed and painted and all of that. And why not just tape lame ducts closed and replace with ductless mini splits and hydronic or electric resistance heaters? So first of all, electric resistance heaters are not particularly energy efficient. Ductless mini splits are a choice. There's some very good presentations out there as to kind of the pros and cons of ductless versus ducted systems. Ducted systems provide the ability for filtration and true air mixing of our homes, and ductless systems don't provide either one of those. And the choice of equipment is once again kind of one of the things that you present in your work scope and your proposal as your recommendations and potentially as good, better, best choices for people. This was going back to my presentation. This was kind of just a really interesting and just telling find in a home. So I found this couch. The back of the couch has this, this dirt pattern that's absolutely outlining as the wall outlet that was behind it. So what that's showing me is that there's absolutely air leakage through that outlet because of the dirt that got impinged on this couch from that. When I was doing the blower door test and showing air leakage pathways, I had the house being pressurized, which allows the smoke gets pushed out of the house so we can visually see it getting sucked through places that are air leakage pathways. And so then we can also see that the smoke was absolutely getting sucked into these outlets. So there's this air leakage pathway through this wall system. Crawled up into the attic and I found that the attic had this white powder sprinkled all over it. And this is an unsealed top plate. And the white powder is absolutely sprinkled all over these unsealed top plates. So this was a termite insecticide called Termidor. I researched to see just how safe this insecticide is, since it was obviously being pulled down through this wall system and has a wonderful air leakage pathway into our home breathing environment. And so what I found is that the main ingredient is something called fipronil. It causes skin irritation, sweating, nausea, vomiting, headache, stomach pain, dizziness, weaknesses, or seizures. The EPA classifies it as a possible human carcinogen. The safety data sheet says to take off all clothing that comes in contact with the chemical, to wash the skin with plenty of soap and water, to seek medical attention for skin irritation, to not inhale, to get into fresh air. So the point of this, that I'm giving you all these details, is for you to understand how houses work as a system. And it's the auditor's job to do this kind of research and then relay the information to our clients, as well as to keep ourselves safe while we're doing our jobs. Crawling around in attics and crawl spaces, we're exposing ourselves to all these various things. And so it's important for us to know what they are and how to take care of ourselves. And I know that these pesticides companies, and in speaking to this homeowner, told them that the treatment was perfectly safe. They're doing it in the attic, and it's perfectly safe for the occupants. I've also found this same treatment in crawl spaces. And it's important for us to understand that other trades don't understand how pressures and temperatures cause air movement, or how natural driving forces such as stack effect cause air movement, nor how interconnected our attics and crawl spaces actually are to the interiors of most of our homes. And that's part of what distinguishes us from the other trades and from other contractors. This, one of the other things that we need to look at is how are the dryer vents, clothes dryer vents vented. Our gas clothes dryers are venting hot, moist air, lint, carbon monoxide. So having a restricted dryer exhaust vent can potentially cause carbon monoxide in our homes if that laundry room is in the house. And so in this situation, the laundry room was in the house. Looking back behind it, I see that there's this incredibly restrictive bend right off the bat in this flex duct that with dryer vents is never pulled tight. So that right off the bat is restrictive. Then there's this huge turn, another huge turn. This is the crawl space actually right on the other side of this wall. So this great big opening between the house and the crawl space. And then when I went into the crawl space and crawled around, I found the vent and it just went on and on and on. So this was completely against building code in terms of the length, and there was no additional powered fan to help the exhaust from this dryer actually vent out. We've got these P traps where moisture can condense out of the air and end up settling in these areas, as well as lint. And this also becomes a possible fire hazard. So this is all kinds of safety and indoor air quality issues. Finding a vent like this, and so once again, this is something that on the one hand is fairly easy to fix, and we know what needs to be done, that the run can't be that long, there shouldn't be the dips, there can't be the restrictive turns in our dryer vents. And then there's clues to pressure imbalances that we should be looking for inside the house. So when we see the smoke pattern on the outside of a fireplace, we know that there's been some kind of pressure imbalance. So is that when the heating and cooling system is turned on, or the kitchen exhaust fan? There's some kind of pressure imbalance that is happening in this house when they have a fire. Then the smoke is not all going up the chimney. So is there a problem with the chimney? The same thing with our furnaces. This is a clue that there is some kind of pressure imbalance going on. We're getting negative pressure outside of the air handler, which is actually pulling either the combustion gases or potentially flame out of the air handler instead of into it. So we definitely want to find things like that and point that out to our homeowners in our report. Same thing happens with our atmospherically drafted water heaters. Just looking for clues that tell us that there's pressure imbalances happening. And then during our combustion safety testing, that's one of the times where we can get a sense of whether we can make that situation happen in the house, which then tells us, what we need to do to not have that situation be able to happen by itself, or for our occupants to unintentionally make it happen. Air leakage pathways are huge that we want to find and fix in our homes. And so they can be something, just they're obvious and they're little. They're, this wire is going up into the attic and it's not sealed. Another place is behind this molding. The drywall is probably not actually attached to the top plates. And that's something that we can go up and look in the attic to see. Seeing a ceiling like this assembly tells me that basically this whole ceiling assembly is one large air leakage pathway. And then I can prove that with the blower door and smoke to see where the smoke goes. Definitely the can lights going through this assembly are air leakage pathways as well. So I'm just going to read a question that somebody, or a comment that somebody has put in, and see if I will respond to it. I am not here today to talk about grants and low interest loans, or any of the incentives or anything that goes on. And yeah, money is absolutely, budget is absolutely a constraining part. But it's one of the things we're trying to do as energy auditors is to prioritize for people what can be done, and also let them know what potentially can be staged or not, so that they can do something over time. and let them know when it's not actually feasible to stage things. So that's part of what the energy auditor should be doing for the individuals. And also, we have to start making people aware that everything is not low cost. Our time and expertise does cost money. We need to live and stay in business as well. And if you want things done and the proper attention paid to the details that need to be paid to, that all costs money. And I feel that there is a tremendous fallacy out there of the real cost of things. And people need to get a much more realistic understanding of what the costs are. And so some people are writing in some things. So I'm not going to comment upon what they say unless I see something that is just terribly incorrect. So I get in the question, how does one become an energy auditor in terms of education, certifications, career pathways? Is there a short? There is absolutely a shortage of energy auditors. You basically need to do self-education in building science and construction to become one. There is no real certification out there. I started out with basically with the knowledge that I had at the time, came back from homes, wrote reports to the best of my ability, letting the homeowners know that, and then turning to the people who I found as mentors to show them pictures that I took of things that I didn't know or understand, so that the next time I went out to a house, I knew more than I did from the last house that I went out to. And that is really mostly the path, is looking things up, researching things, and self-study. So more air leakage pathways. Typically, when we're in a house, we don't get to see things like the stairway without, say, the carpeting or the finishes. In this house, they were working on this house, and the carpeting was all pulled up. And so I already knew that stairways are very typically air leakage pathways because they're not sealed well. All of these things are just covered up with the various finishes, particularly carpeting. And often you'll see the heavy dirt line at the kind of at these right angles in carpeting. And once again, people feel that they're terrible at cleaning their homes because they just can't get that dirt up. And where is that dirt coming from? Well, they don't have a chance. The dirt gets impinged in the carpeting from these air leakage pathways. And so this is one where it being open, I thought, was a good example to show you those pathways. And then often, the baseboards are covering up air leakage pathways. That's what a lot of our contractors seem to think that the trim is all about, is actually to cover up kind of the ugliness that's behind the trim. So this was a house where some of the baseboard was missing. And so I was able to actually see the air leakage pathway. And this is actually above a garage. So this air leakage pathway below this floor of the garage, of the ceiling of the garage, is another pathway of very potentially bad indoor air quality should they leave their car running in the garage and then have somebody else, and somebody else is sitting up in this room. Ventilation. Ventilation is really important in our homes. And it's very poorly implemented in the majority of our homes. And that's both the just basic exhaust ventilation as well as whole house ventilation. In our older homes, they used to have just a passive hole cut in the ceiling above the stove. And in a lot of homes, what I see is that the hole has been blocked off, but no actual kitchen ventilation has been added. In a lot of our closets and pantries in older homes, holes were cut and a little screen mesh was usually put in. And this was supposed to be ventilation in our older homes. And so a lot of our homes still have just these holes in closets and pantries. And these are just huge air leakage pathways and contribute to poor indoor air quality, as well as losing our conditioned air. So identifying these things and explaining to people that they need to be sealed up and that we need to actually put in good ventilation systems is important. This is what we'll often see when we open cabinets in slightly newer homes than those ones I showed you in the last picture. But we need to open up the cabinets above the stove, the stovetops, which is typically where these are, and see if there actually is ducting for the venting of the combustion byproducts of cooking. And even when we see that the venting, the ducting is there, is it actually air sealed? Are they using something other than just duct tape to seal it? Do we have, are the seams actually sealed? And are there other air sealing penetrations happening through that part of the assembly? This is kind of everything that I saw, right? So in the house, I opened the cabinet and I saw that there was a vent. I saw that it is sealed at least with the flex tape rather than a duct tape, but I'd rather see mastic. I'm seeing that it's the flex venting, which really should not be in with a kitchen. It should be smooth sheet metal. And there should be no mechanical fastening through this. So I'm not seeing mechanical fastening, but you should never ever see any screws going through the sheet metal of the kitchen exhaust vents, because we don't want any place for grease to build up and potentially be an area where a fire could start. So I see that it is, at least that there is a semblance of a vent. I can't see at the top here what's going on inside the house at that termination. So when I was up in the attic, I crawled on over to the kitchen exhaust vent and I see that it's not air sealed to the drywall, and it's very difficult to air seal to something with all of these grooves in it, but there was not even an attempt to air seal. And then when I looked up to see how it was actually vented, I see that basically it's just kind of pointing towards the outside. It's pointing towards a hole in the roof deck. And so it's not actually positively vented to the outside. There is not a connection that's actually making those exhaust gases go to the outside. Those exhaust gases can absolutely be spilling into the attic. And so that's not a proper installation. Moving on to other things we should be looking at: insulation, contact, airtight, recessed can lights. Very, very hard to tell by just looking up at a can light. Just don't know. Are they or aren't they? So one of the ways that we can figure that out is by removing the trim ring and looking up into the light fixture itself, and finding this orange label will tell us. Also, often in the model number, it'll say ICAT, which is insulation contact airtight. Not all of the cans are ICAT. Some of them are only insulation contact. The airtight just tells us that they don't leak as much as the older recessed lights. But ideally, we do want the ICAT. Some other safety issues that we may find in our homes are we can't have flex gas line going through the air handler cabinet itself. This needs to be hard metal going through the air handler cabinet. In an earthquake, the flex lines can be severed by the air handler cabinet being shaken around. So that's code, and we should be looking for things like that. Seeing any kind of rust or corrosion or white residue tells us that there's a venting problem. And so I'm going to quote part of an article that was written by Jim Davis. Jim is one of the most experienced and knowledgeable persons when it comes to carbon monoxide and combustion testing. And so Jim wrote, anytime you see rust on burners, heat exchangers, draft hoods, or flues, you have venting issues. These are accidents waiting to happen and must be corrected. Also, if you see a white powder-like residue on the flue pipes, draft hoods, heat exchangers, burners, etc., you have venting issues. Don't overlook these telltale signs of potential danger to your customers. So after you've done your whole interior inspection, it's time to get into the crawl space and the attic. And then throughout your whole inspection, you're looking for for any reasons that a test you may want to perform is not safe to perform, as well as deciding what tests to do to provide you with the information that you need to be able to present a comprehensive work scope for the homeowner. The attic and the crawl space is where you're typically going to find the issues that may tell you that it's not safe to do a blower door test or a duct test. So it's important to do these investigations before setting up your diagnostic testing. This is an major air leakage location in the attic where all the electrical is going down through the wall system. Looking at a crawl space, crawl spaces are not dry spaces. This white stuff is called efflorescence. What it is it's the minerals that are left behind when water vapor moves through something like concrete or even the soil, and it's in vapor. The water is in vapor form, and it's any minerals that are in the water are getting left behind, and that's what this white is, and it's called efflorescence. So it's a clue that water vapor is moving through the whether it's the soil or the stem walls or wherever you're seeing it. This crawl space I found to be very interesting because I'm crawling around down there and I'm actually seeing, this is not the only one, but I'm actually seeing plants with green leaves in this crawl space. So this obviously, this powder dry appearing crawl space was definitely not dry. Plants were able to grow. This was, a tree that somebody, chopped away under this crawl space. This house had been here, for, I think it was built in the 60s. So don't think that our crawl spaces are dry spaces. And moisture transmission from sandy soil can transmit far more moisture into a home than a crawl space with standing water. It's all about surface area. And the surface area available for evaporation in granular soil is far greater than the surface area of the same space covered in standing water. So even what appears to be powder dry soil is still evaporating moisture. And we need to do a thorough investigation of the crawl spaces, guided by, our understanding that even when we don't see obvious signs of moisture, moisture is evaporating. Air carries water vapor, mold spores, and other objectionable particles upward into the house. So unless the connections between the crawl space and the house are sealed tight, which there typically never are, especially in a house that you're actually being called out for an energy audit, there's going to be that connection between the air in the house and the air in the crawl space. And so during that exterior inspection, we should have been looking for perimeter drainage problems. And even if there wasn't drainage, we would be looking at the landscaping, the sloping of the landscaping. Is the dirt actually up above the wall system, the sill plate, the slab of the house? But recommending a ground source vapor barrier in pretty much all cases is always a good idea in any house. this was an interesting discovery and story. This is not a house that I did the audit on. This is actually the picture from one of the first interesting moisture fixes done by a home performance contractor up in Mount Shasta. And this was a house that was built in 1993, and the house was only 3 years old when the home performance contractor was called in. And from the moment that this two-story house was built, there had been condensation problems on their dual glazed aluminum framed windows all winter long. And now Mount Shasta has, cold winters. They have about 6,000 heating degree days compared to the Central Coast 2,300 heating degree days. So anyway, water was dripping off these windows all winter long. The wood window sills were warped, they were stained. The homeowner had to keep towels on the sills to absorb all the water as it dripped. The drywall that was in contact with the window frames had black mold growing on it. When the contractor was in the attic, he noticed that anywhere roofing nails penetrated the plywood roofing sheathing, the nail tips were rusty and the plywood had started to decompose from moisture around those nails. So there was moisture all the way through this two-story house. The only place that the contractor worked to fix this moisture problem was in the crawl space. The house was on a raised foundation, and he went underneath. He laid out plastic on the soil. He overlapped it, but he didn't seal it particularly well, but he covered the ground with it. He went around and found any penetrations through the subfloor. So he did a full air sealing work scope between the crawl space and the house. And then he temporarily sealed off most of the venting for the crawl space. And we legally can do this when we lay down plastic on the ground of the crawl space. So this plastic layer is called a ground source vapor barrier. And within a few days, all of the moisture problems in the house were gone. The windows weren't changed. The only thing that was done was putting down this ground source vapor barrier and sealing the penetrations between the crawl space and the house, and then closing up the crawl space vents. So it probably seems counterintuitive to find that eliminating the crawl space venting could actually solve a moisture problem. I mean, it was more than just eliminating the venting. It was that ground source vapor barrier as well. But it's been proven in the majority of climates all across the United States, and particularly in the Southeast climates, that we have to eliminate crawl space venting to make our houses dry. And that was this contractor's experience after he read the literature and he gave it a try. And so all that work, including the ventilation, the ground source vapor barrier, stopped the condensation on the windows. So it wasn't a roof leak that was causing the rusting of those nails and the deterioration of the plywood. It was all that moisture coming up from the crawl space and getting trapped within the house, causing very high humidity levels in the house. So we often need to think, I'm not going to say out of the box, because this is the way we should be thinking when we understand building science and heat and moisture flow and airflow through our homes, but it's thinking differently than possibly that first intuitive thought, and the way that other contractors think who don't understand building science, that those rusting nails gave the final clues that the moisture was moving all the way up through the house. So here I'm showing some efflorescence that's not on an exterior wall. So this isn't from, say, landscape irrigation that the efflorescence is happening, that moisture is coming up. There's also efflorescence back here on the soil. It's coming up through our soil. And this is a picture of what a very, very nicely done ground source vapor barrier might look like in a crawl space. There's all kinds of air sealing opportunities in the crawl spaces. And so that contractor did, full air sealing work scope in the crawl space that he was working in. And so we'll see all the staining, but we'll see these, big holes and little holes. And all of that is interconnectedness between the crawl space and the house. And so that's moisture and indoor air quality, that's losing our conditioned air, that's helping stack effect be even stronger, which we want to lessen and mitigate stack effect. The underside of bathtubs are always huge holes in our crawl spaces. There's deferred maintenance issues also in our crawl spaces as well. And sometimes it's not necessarily important to know how or why these things happen, but the fact is to bring to a homeowner's attention that they've got these problems and that they're going to end up with water leaks if they don't get these things fixed. If you do see this green corrosion on copper pipes, that does mean that the plumber basically did a sloppy job cleaning up their work. They didn't clean the flux completely off the pipe when they did the soldering. And so now the pipes are actually corroding because of it. So this issue was caused by basically a sloppy plumber. So not necessarily important to know that. It's, nice to often kind of know what's going on and to help a homeowner know that maybe they should interview their plumber or tell them that they expect them to be very careful and to clean the flux from their pipes when they fix them. What was the humidity level in the Shasta house? I don't know what the actual humidity level was. The humidity level overall doesn't necessarily, the relative humidity level of the air doesn't necessarily tell us what, what's going on. The windows were coming to dew point. The windows were getting cold enough that they were at dew point for the amount of moisture that was in the air. And so, I don't necessarily know. In all probability, he did measure the relative humidity and potentially some of the surface humidity levels as well, but I don't know. What mill crawl space vapor barrier do you recommend? There's just all kinds of great literature out there. And so if you're looking at crawl spaces, I would say to take a look at the literature. Definitely 6 mil minimum, absolutely. But there's so much great information out there about ground source vapor barriers right now. Stego has all kinds of information and materials for that. So you can look up Stego, Stego. What are the best materials to use for the air sealing of crawl spaces, of penetrations and openings? The materials have changed. 15 mil Stego, that's awesome. That's fantastic. The materials have changed in quite a bit over the years since I have been doing energy audits. We used to use a lot of 1 part low expanding spray foam, but there's lots of better things now, but you kind of need a whole toolkit of materials because the different holes all just kind of relate to the materials differently. So there's all kinds of great air sealing tapes now. Mastic is actually an awesome material that can be used not just on ducts, but for air sealing. There's with like the underneath the tub, we need to block and seal that. So you need to use either plywood or drywall or one of the foams, a polyiso foam or an XPS or an EPS, cut that to shape and then attach that, foam that into place and make sure that that's sealed. So that's a whole other webinar as to how to actually block and seal and do air sealing. The other thing is something else the auditor might find is disconnected vents. So this is in a crawl space. This return is basically completely disconnected from the air handler. So the return air is mostly crawl space air that is coming up, is getting pulled through this return duct and going back up and being redistributed into the house. And it's also uninsulated as well. Indoor air quality. We find, unfortunately, critters that have gotten underneath the house and didn't necessarily make it out from underneath the house. In attics, we often find rats in all of their droppings and excrement. So it's contaminating the insulation. It's creating a definitely not a good, safe airspace. This is just a typical top plate, needs air sealing. Pretty much all of the top plates in all of our homes have not been air sealed. So there's all kinds of air sealing opportunities in the attics. Just goes on and on with all the penetrations that are happening in our attics. So all of this is just pointing to that there's tremendous air sealing opportunities in our attics and crawl spaces. And as energy auditors, you find them, you present them to homeowners to help the homeowners understand how air is moving through the house, how they're losing their conditioned air, how it's causing indoor air quality problems. If you're able to do the blower door test, then you're able to quantify that air leakage as well and help the homeowner understand the benefits of an air sealing work scope. This is a huge interstitial cavity. Often I'll find cavities that actually you can see all the way down into the crawl space. So from the attic to the crawl space will be basically kind of a chimney effect through the middle of a house. These are drop soffits. This is over a kitchen. The kitchen had soffits. These are the drop soffits that are just completely open, not insulated properly. So that all needs to be fixed as well. And then insulation. We need to figure out kind of the quantity as well as the quality of the installation of the insulation. When we can get into a crawl space or an attic, we often can get our eyes on the insulation. Walls, we typically cannot see the insulation, so we have to probe or look in infrared. This is actually an infrared picture of an attic knee wall. This is not the same knee wall, but this is an attic view of a knee wall. And so this is showing me that the insulation is not performing well in this attic knee wall. And if I'm able to see that knee wall in the attic, I'd be able to then visually see, possibly missing insulation or just very poorly installed insulation. So when we can see the insulation, we can get an assessment of how well it's installed. But even then, it's difficult to determine the actual functioning R value of the poorly installed insulation. And once again, figuring out, is there insulation in the walls? So we often need to ask homeowners what they know, what they think they know, probe and use the infrared. Here we've got you'll see that part of the attic will be insulated and then there'll just be these areas of missing insulation. This is a chart that you can use to give you an idea of how to derate the insulation based on what you see. And so what this is giving us is kind of the percent of voids in insulation. So you need to make a guesstimate of the voids that you're seeing in the insulation. And then this is telling you the net effective R value based on the percentage of voids. And I think the biggest takeaway is that even with just at 1% of voids, the effectiveness of the insulation of all these different values of insulation drops by close to 50%. So poorly installed insulation very quickly is not performing at the R value of what that bat in particular is rated at. And then blown-in insulations are harder to tell what's going on with them. But basically, you're going to measure the thickness and then look at charts to see what is the actual insulation value at that thickness. Sometimes we find, just truly lacking insulation, which on the one hand is kind of great because then we have clear path to do air sealing and insulate the attic properly. These are cold water lines that are running basically kind of midway up in an attic, and this homeowner, they had a toddler who was learning how to turn fixtures and things like that on, and they were trying to figure out why in the summer the water from their cold water side was coming out pretty close to scalding hot. And it's because they had uninsulated cold water lines running midway up in this attic that was getting very hot. Looks like I need to really move. Okay, so poorly installed ducts, under insulated ducts, broken ducts. We find all kinds of things. Wind washing. Wind washing happens in both intentionally ventilated bays in attics as well as unintentionally ventilated bays. So in the unintentionally ventilated bays, we need to recommend air sealing at the fascia there. And then in intentionally ventilated bays, we actually need to have baffles so that the air can still ventilate the attic, but goes up at the roof deck and doesn't blow the insulation away from the edges of our house. Some attics are, this is actually the same attic. It had some airtight cans, and it had some non-airtight and non-insulation contact cans. And the cans that should not have had insulation in contact with them. This is a fire hazard for this kind of can, had the insulation right up against them. And then these newer insulation contact cans had absolutely no insulation around them. Ventilation. Even if we see ventilation in the ceiling of the bathroom, we need to determine if it's actually being vented properly. In this attic, the bathroom fans were actually vented into closed dryer lint traps. That's not proper ventilation. This, unfortunately, I see way more often than I should, is that there's the ventilation fan, but there's absolutely no vent duct whatsoever attached to it. This is more of just kind of pointing ventilation to the outside in a number of different ways. This one isn't even bothering to point it outside. This is what I mean by positively attaching the duct so that all that exhaust air or vent or combustion gases or anything else actually goes to the outside. You need to use roof caps that have a collar so that the duct can actually be attached to this collar, and this collar goes into the vent cap, and so that the air actually, any exhaust air, any combustion air, the gases go to the outside and aren't just leaking back into the attic. And so this is one mounted for a balanced ventilation system, actually on the outside of a retrofitted house. Junction boxes need to have covers. You're going to find this all over attics, is that the junction boxes are not covered. So before insulation is re-blown into this attic, or the attic is insulated, these J boxes need to have covers put on them. So not hard to do, not a big deal to do, but needs to be done. This is one of those non-negotiables if they are going to end up below insulation level. Fire hazards. Chimneys need to have clearance to wood. The vents of water heaters and furnaces need to have clearance to wood. They cannot be touching the wood. Craft-faced paper is not to be left exposed in the attic. There's even this warning, and it says, this facing will burn. Do not leave exposed. Cover with approved building material in contact with facing. Breaches in the firewall. So this is a garage on the other side of this wall, and we're not supposed to have breaches in the firewall between the house and the garage. So we should be looking for those and discovering them, whether they're in, the attic or the crawl space, or, where they might be. This is an asbestos covering on ducts. So this is the kind of thing that when I see ducts covered in asbestos, and particularly when it's broken and falling apart, this is friable. I can't do a duct test, and I need to decide whether it's safe to do the blower door test or not. I potentially could feel that it would be safe to pressurize this house for the for the blower door test. But I need to make that decision based on the air leakage paths that I'm seeing and how bad I'm seeing something like this in the house. And I'm absolutely not going to do a duct test on a leaky duct system with friable asbestos like this. So that's, so I won't be able to give that information to the homeowner of what their duct leakage number is, but seeing ducts like that, I can say with confidence that they need to be replaced. Here's some other asbestos containing materials that you may see in the attic. And even often after asbestos remediators have been in attics, I find pieces of asbestos containing materials laying around in the attic. So done our interior inspection, our exterior inspection. We've crawled the attic, we've crawled the crawl space. And the energy auditor does not necessarily need to crawl every inch of the attic or crawl space. We're trying to get an idea of what is going on in those spaces to get enough information to help us tell the homeowner what best needs to be done for their home. We would be spending more than 6 to 8 hours if we did complete crawls of all those spaces. So we need to move on and look at the mechanical systems. And this is where a lot of our diagnostic and performance testing starts to happen. And so looking at our mechanical systems and possibly doing our performance testing. Here is a list of the various performance testing. I don't have time to really talk about all of them, or definitely not to teach them. There is a webinar coming up where I'm going to talk about the blower door basics and beyond. So you can look for that webinar. But the home energy auditor needs to have all of these tests in their repertoire, and then it's up to them to make the decisions of what to do on that day of the testing. So the blower door, it helps us quantify air leakage. It helps us find, actually locate the air leakage. It enhances the blower door, the infrared diagnostic testing, and just being able to see things better with the blower door, it helps. And then it's a necessary part if we're doing the duct leakage to the outside test. With the blower door, it helps us to identify air leakage pathways. When we pressurize the house, we can see the smoke leaving. With the infrared, we are able to see temperature differences. And so by seeing temperature differences, we can identify air leaks and thermal bridging. We can potentially use it to see if there's insulation that's missing, if it's poorly performing, if it is actually there, and we can also identify water leaks. It's difficult to get a temperature difference in some of our climates, so like the Central Coast, or even where I am in in Southern California. On mild days in the shoulder seasons, it's hard to get a good temperature difference for infrared. Duct testing, there's a number of tests we can do with the duct blaster. Total duct leakage to the outside, and the half Nelson. I typically won't do duct leakage to the outside because most of the ducts that I'm examining are all outside the building enclosure. The half Nelson tells us which side of the system is leaking more, the supply side or the return side. The duct equipment can also be used as a power flow hood. It can also be used for a very tight house for the blower door test, and we can use it to accurately measure the total airflow from the air handler. So the system airflow of a system. The flow finder or the low flow bolometer are airflow measurement devices for supplies in particular. And so for doing delivered system capacity, we need equipment like this to measure our airflows and to measure the airflows out of our exhaust fans. This is the heating stratification test. So just an important and good test to do to figure out how well the house temperature stratification is, the heating system sizing, and the loss across the ceiling assembly due to stratification of the air. The delivered system capacity is a fantastic test to do. It tells us literally out of this total system capacity. So say you've got, a 40,000 BTU furnace and is all of that being delivered to the house? And this test will tell you whether you do it in air conditioning or heating, whether 50% of that capacity is being delivered or 30% or 80%. So we need to measure temperatures at the grills, and we need to measure the airflows, and then do some calculations to determine that. Doing total external static pressure on the air handlers kind of gives us a blood pressure reading for the health of the system. Air handler watt draw and condenser watt draw using a true power clamp meter, and something like a kilowatt is also needed for those systems. And then testing pressures across doors. We don't want more than 3 pascals across a door when the heating and cooling system are on. So we need to be measuring pressures across the doors. And then we can also measure the watt draw for pool pumps. And also get a sense of how long the pool pump is running. Pool pumps are huge energy hogs typically. There's great variable speed pool pumps out there now, so making the recommendations to change out pool pumps to variable speed pool pumps. Then there's all the combustion appliance testing. So we need to go through all of that. This is that white residue that Jim Davis was talking about in that article that I quoted. If you see this, you know that there's some kind of venting problem for that appliance. Here's a list of the various combustion safety tests that the auditor is going to be doing. This is a gas leak that I found on a gas stove. The homeowner was smelling gas, and I was able to identify where the leak was with my bubble solution and my gas sniffer. These are hazardous conditions that you're going to see. This is a furnace vent that obviously has a connection issue. This is a temperature and pressure relief that is going into a glass jar that's hot, scalding steam and water. That glass jar could shatter. This is an indoor closet where this water heater is. Very unsafe condition. So the home energy audits, we're gathering all of this information. We need to understand the building science and the climates that we work in, and we need to figure out the air and the heat and the moisture movement through our homes. Thank you. So just wrapping up with kind of that report writing. After you gather all of this information, you need to compile it into a report. And so my suggestions for report writing is to provide the report. You're showing the, a preliminary work scope, prioritizing your recommended measures, presenting options and say good, better, best. You want to restate your homeowner's concerns in their own words so they know that you were listening to them. And understanding them, describe the existing conditions and results, make recommendations describing the benefits of those recommendations, and provide test data and pictures. So having something like a cover sheet, be as creative as you want, list the concerns, your measurements and observations, and then in part 3, have your recommendations and ballpark costs and benefits and anything else. Then develop the work scope. It's great if you can develop at least a preliminary work scope for the homeowner to consider. And this is what typically might be in a work scope after an audit examination. So in summary, the audit is an opportunity to fully inspect the home. It's, you need to use all of your observational skills, building science and construction knowledge, use diagnostic testing to further inform your observations, and then provide the recommendations and create a work scope that provides value to the homeowner. So I know that Itzel has a few closing things to say. Ran it right up to the last minute there.
Yeah, thank you, Judy, for that. Just really quickly, if you have any questions about learning units, I'll drop our email. We have AIA available units and then coming to your inbox, slides and the recording. Be on the lookout for that, and just some upcoming classes for the month of February. I'll drop the link to the calendar if you're interested in registering or looking at more in-depth descriptions. And with that, I'll hand it back to Judy. Oh, one more thing before I forget. We have our energy code coaches that are local experts and will help you answer any Title 24 questions. So there's the phone number and also an online page to put your inquiry in there. But with that, I'll hand it back to Judy just in case there's any additional questions left. Yeah, thank you.
Okay, so I'm seeing that is there an organization for home energy auditors? Not one that I'm aware of. So Judy had mentioned a workshop about performance testing. Was that one of the events listed on the 3C page? There is a performance testing in-person training coming up. It will be in, if it's not already in the calendar. Actually, I think some people have already registered for it. So it is there on the 3C website that hopefully we will get to show you what some of the performance testing is. The website, the one that I mentioned was Blower Door Basics and Beyond. And so that should also be in the 3C catalog. And that is a 2-hour webinar where I have to talk really fast to give you all the information that is important about blower doors.
Just drop the links in the chat for those two events, just in case anybody wants to register.
Great. How does one find an auditor? That's such a good question. That's just a good question, Rebecca. I don't have, I don't think I have any suggestions for you as to how to find an auditor. When I proposed this webinar to 3C I was it was truly meant to be to originally actually be longer and part of a whole home performance training where we would be training people to be auditors. And that didn't really come to fruition. And so somebody's saying CalCerts or BPI. So CalCerts, they're HERS raters. They're mostly not home energy auditors. Some of them might be doing home energy audits, but mostly you're just going to find people who do HERS rating. BPI. BPI is mostly concerned with combustion safety testing and is not really training people fully to be home energy auditors. So really interview anybody that you find to find out exactly what they are marketing themselves as in doing home energy audits. And so what counties do I serve? Orange County, Los Angeles County, I'll go up to Ventura or sometimes Santa Barbara, but that's getting pretty far away from me, so I have to start charging travel time. And to be, I don't know, just to lay it out there on the line, I when I do not have a contractor in the area that I'm doing an audit in, I tell the homeowner that and tell them that I can tell you all day long what's going on with your home and what needs to be done to fix it, but I'm not a contractor. And if I don't have a contractor in your area, I have serious doubts as to whether you're going to be able to get your home actually fixed in the way and in the principles of the whole house system and building science. We don't have a lot of contractors who are actually doing that work properly. So there's we've been trying to train the contractors, we've been trying to train auditors. As I started this presentation out, I was saying that this really is a great model for a contractor to actually do the energy audits. We're trying to train a workforce, and it's definitely been a slow uphill battle. Do I have time to compare and contrast HERS raters versus home energy auditors? Are HERS raters contractors who audit homes? HERS raters are third-party inspectors for building code compliance. A home energy auditor should be looking way beyond building code. Building code is basically the line in the sand between legal and illegal in terms of building a home. So whether that is doing work in a retrofit or building a new home, the HERS inspectors are code compliant special inspectors for certain energy features. That doesn't mean that some of them have not, learned building science and taken other training and can do other things. But as a HERS rater, they're not home energy auditors. There have been in the past a few programs where the HERS sponsors, so that's the organization that certifies a HERS rater, have attempted to do things with these home energy scores and these energy efficient mortgages and things like that. And so they've come up with these software programs that you plug all the information in, and it supposedly gives you the cost benefits, and they're not really very accurate or particularly helpful in prioritizing what really is going to do good for you and your home and your indoor air quality. Okay, so somebody's running a workforce development program in SAC to train auditors and retrofit project managers. That's awesome. Electrify My Home is, they're an electrification company, and they're just hell-bent on installing heat pumps in your homes, and they don't really do much in terms of air sealing or insulation or anything other than doing heat pumps, which is great, and they do good work. Balance Point Home Performance is a very, very good home performance contracting company. They do their own energy audits, they do their test in, they do their test out, they commission their work, they design all their, they design their work, they're a full home performance contracting company. So lots of homes that have mounting deferred maintenance but need additional money to do audit and improvements. Yeah. Okay, so I don't know who contracts out air sealing. You're probably talking about Electrify My Home. Yeah, if they can, the Electrify My Home's focus is not necessarily on improving the building enclosure, but yes, they understand that, and they'll contract it out. So those are up in the Bay Area, and this is, and so we thank you all for, listening in on this from all over the state. And yeah, so sounds like there's a few people out there with some good resources in Northern California that you can reach out to if that's in your area. So this is a good question. Have I found an instance where a home can be too tight and air quality is compromised? Well, the point of our homes is actually to be able to control our indoor air quality. And basically the only way that we can control our indoor air quality is by making the home tight, but then we have to include proper ventilation so that we are controlling the indoor air quality. So is the home too tight? No, the home's not too tight. We want the tight home, but we cannot just tighten a home and not provide the ventilation and the filtration so that we end up with safe, good air quality. Okay, so Maximilian feels like he's got all kinds of recommendations, so you guys can read his various recommendations. That's awesome. Thank you, Maximilian, for that. All right. So I think we had a nice full day. Thank you everybody so much for attending. I hope that you all got something out of this. I'm sorry that there are not, organizations or lists that, of references that are out there for you. But the more that people are looking for these things and understand what they should be getting, the more that will be able to get people actually wanting to, do it and seeing that there is a niche for them.
Thank you so much, everyone. Have a great day.
All right.